What's up, everyone? Hope everyone's year is off to a good start. It's pretty busy here already. For us, we're getting ready to build out another lab on the floor above us, so that's keeping me pretty busy, among other things. But I wanted to do a video on a piece of equipment, another teardown video, a little bit of troubleshooting. I think this instrument is really cool. It's not my favorite instrument for other reasons that I will go into, but I thought it would make a neat teardown video. There's a lot going on inside these, and the instrument we're looking at is this guy right here. It's the PerkinElmer, which I believe they're now called Revity, or at least one of their companies is. I think PerkinElmer still exists, but anyway, this is the Envision 2100 series. This one is the 2104 multilabel reader, and with that, it's a plate reader, so it can do fluorescence, absorbance, and luminescence. So these can be used for a variety of different applications, obviously, and which I'm not going to get into any detail because I'm not qualified to do so. We're strictly talking about it from the electronics and the internal electronics, how it works, the mechanical nature, all of that is what we're going to get into with this instrument. What I do want to start out with, though, is just a quick note on these. If you're planning on buying one, I would, yes, they provide great sensitivity. I believe, for example, luminescence, it's down to 75 picomolar of ATP. But there are other instruments that can achieve that sensitivity. And the reason why I suggest that is because from a service standpoint, PerkinElmer keeps the calibration tools for these proprietary. And what I mean by that is that with some of the other spectrophotometers we have, or plate readers, like, for example, molecular devices, they will sell their customers test plates. So plates for absorbance, fluorescence, luminescence that you can run yourself to qualify or QC your instrument, and you can send them out for certification, and that way, if you're in a regulated environment, ISO, GMP, whatever it may be, or GXP, you can do that test in-house, and you can even do some diagnostic tests with that. You can validate repairs with them. You can't do that with the Envision because PerkinElmer keeps the tools proprietary. There are certain tools that you need to ensure that the measuring head is coming down to the correct height. All of these things that need to be checked with standards that PerkinElmer does not sell to their customers. And so what does that mean? If you want one of these, you really can't avoid a service contract. And if you work in the lab, I'm sure you know, service contracts, they're expensive. And so, the purchase of one of these, and a lot of instruments, that cost does not end with the instrument. All right, so it's something that you really want to consider, especially with these, because that's one of the ways they get you. And all these companies have their little tricks to do that, and I'm a huge proponent of right to repair, and I love circumventing those tricks. But in some cases, like this one here, there's really not much you can do. That's the one thing I'll say about these. It's really the main downside. But anyway, let's get started. I started on this one because it's got some really nice lighting, so you can get a nice view of the instrument and what it looks like from the outside. But I'm actually working on another one not far from here. We have two of them, where we can get in some details. I also have a parts unit which I'm going to be referencing so you guys can see a bit more of the internals. One quick note for servicing these: this whole piece, this shell, it actually comes off. Alright, so there's some screws on the bottom and then in the back where you can literally pull this whole thing off to get easier access. You can pull this part off. Yours might not come with this. If you own one of these, this is for feeding in plates. So you've got like these towers that you can add. So this is the plate stacker, that's what they call that, and it will automatically load plates if you have a number of plates to run. All right, and this also is, you can remove that as well. All right, so anyway, let's dive right into this. I'm excited about this one. So I think this conveys why I wanted to do this video in the first place. This is a good representation of what you get out of the manual for the Envision in regards to how the instrument works. This is a diagram of the optics for the instrument with the circles and the rounded rectangles and the pentagons representing light sources, detectors, mirror modules, and the filters. And of course these lines are the optical path, which, I mean, it just seemed, it to me is lacking a bit, but you can really see just how much this instrument can do. You've got all these modes, all these different fluorescence measurements that you can do, like TR, time resolved fluorescence, and absorbance and luminescence. But you know, I thought it'd be cool to do a video on actually diving much deeper into the instrument. So let's just start with the light source. And as I said, this is a xenon flash lamp. And so you can see that right there. And these types of lamps are pretty common in spectrophotometers and plate readers. They require a high voltage, and so thanks to our parts unit, I actually have one of the light source to one of these right here with the case off, and you can see this is the xenon lamp. It's a big lamp, and I don't see a make and model on it. This just says ROHS exempt, so that's not having anything to do with it. But again, as I mentioned, these lamps, they require a high voltage supply, and you can see some of that here. This is basically your step up transformer. It's going to be taking a lower voltage and stepping that up with this transformer, and you've got what appears to be, this is also a switch mode supply. You've got a switching transistor here and your filtering caps, and then you can see that further this voltage is being stepped up with the use of a multiplier. You know, and you'll see these in CRTs to step up the voltage for the anode. So that's what that, these are diodes actually with heat sinks on them. All right, so I'm not quite sure what voltage that they're stepping this up to, but that is likely what this circuit is doing. And you've got a big high voltage capacitor there, and then of course this is your coming from that supply feeding into the lamp. Now you can utilize our parts unit a bit more. This lamp is sitting on top of this lens right here, and so if I grab this, it's going to be sitting basically like that. I think might be a position oriented a little bit differently, but the point is that is meeting it with that lens there. And from there, yeah, so there's a device that sits right about here after the xenon flash lamp, and you can actually see an optic cable running from it where it says 3B, right? You can sort of see it there. You can actually see a little stepper motor there with the Acme screw coming out of it. That is the excitation light selector, and I have one of them right here. Alright, so yeah, this is the excitation light selector, and this is just selecting which path the excitation light is going to take. And so in that, it's being controlled by this stepper motor on this Acme style screw, so it can move back and forth, and then it can even home itself with this little actuator, and then this U-slotted photo microsensor. But if you can see here, we've got some mirrors here, so when it's in this position, it's kind of hard to tell, but you have a mirror here that's going to direct the light out this way where it says 3B, and then there's an optic cable that connects to the bottom read head, so you can take measurements from the bottom of the plate. And then this one, as it moves here, you've got another set. There you go. You've got another set of mirrors. Well, you can see directly down into it, which allows the light to pass through this tube here, and it will end up coming out here, and we'll get to where that goes in a sec. But there's also a mirror that is directing the light through this optic cable here, 3A, and I believe this is also the absorbance optic cable. On this instrument, absorbance is read from the bottom at the bottom read head as well. So it's reading it from the bottom and not the top. So this selector is allowing you to choose between top reads, absorbance reads from the bottom, and then also bottom reads that you can do with fluorescence and luminescence as well. All right, so that is what this guy is doing. These things are really finicky. I would not mess with these at all. Do not try to pry them if they're causing errors and they're getting stuck. Do not touch these. Best is to control them through the service mode if you're having any issues or you need to reset it, but do not manually try to reset them. They are a real pain, and this is a part that PerkinElmer will not sell to you directly, so this will require a service visit if it goes bad. But just thought I'd share that with you. So moving on, one thing, speaking of absorbance, and we'll get to this as well, so in between the lamp, the excitation lamp back there, and the excitation light selector, you have some excitation filters. So what's interesting about this instrument, at least in its current configuration, is it doesn't have a monochromator. So instead, you've got all these filters that you can choose from that come out on this rail, and they're barcoded so the instrument knows which kinds are in it. So for example, you've got these all loaded currently in there, and there's also emission filters as well, which we'll get to in a second, but these are in between the flash lamp and the excitation light selector. All right, and they'll pop out on this rail so you can replace them, and then they're also controlled by these belts, which do have the potential to go bad, but I haven't replaced them. They're also double-sided, which makes them a little bit more difficult to source. And you've got one for each, and then those are the stepper motors back there for them. Also worth noting is they're going to be read using these barcode ICs, which are pretty cool. And so this will sit, something like that. They'll sit in there like that. All right, so that's the emission excitation filters. And as we keep going, it's kind of hard to see from this angle. Okay, so I know my camera's not focusing all that well, but you can just about see now that I removed one of these mirror modules, where that's not working out too well. That is basically the excitation light selector with those two little circles there. All right, that will line up with these mirror modules, which again are kind of similar to the filters in that each one of these is different. It's got a different mirror in there and beam splitter to depending on what type of read you're trying to do, whether that be luminescence, absorbance, fluorescence, and so these are also barcoded. And what these do is they direct the excitation light towards the sample, okay? And then they also take that light, if you're reading from the top at least, that light that is absorbed and emitted, depending on what type of read you're doing, will take that light, funnel it back up into the PMTs that sit on top. This is the mirror module assembly right here. Okay, and this is the stepper motor. Okay, so this is the mirror module assembly with a stepper motor and this belt that will drive this guy, right? This is where the excitation light selector would sit. This guy, this pin here, this is basically how this mirror module will home itself. And currently not here. This is where this little daughter board with a barcode reader IC would sit. Now, what can happen with these, and it's definitely happened with our instruments, you can see here that you can actually adjust the angle and positioning of this. And again, try to picture this. There is a daughter board here with a barcode reader IC there. So it will emit infrared light that will bounce off of this white plate or the barcodes, and then will be reflected back to this IC that will read either the barcode or this white homing tape. Now, again, this can be adjusted and positioned, and sometimes what will happen is this mirror module will start acting up and it'll start throwing errors. It won't be able to home itself, and it will be because this guy needs to be adjusted. It could be that the barcode reader IC has gone bad and died, but it's most likely that this needs to be adjusted. All right, so that is a real pain because the screws for this guy are on the bottom of this guy, and we go back to our instrument here. So that would mean you're gonna need to pop this whole plate off, this whole cover off, and it's really difficult to get underneath this to access those screws. It's a real pain, and I wouldn't suggest doing it if you're not comfortable with working on stuff like this. You could make it worse, and you also need to have access to the service mode, which I will get to at some point in this video towards the end. But that is basically the mirror module assembly. That's how it works. And this whole assembly is on what's called the measuring head. All right, and so if we go back to our parts instrument here, you can see that you've got these linear ball bearing shafts on both sides. So this is probably a ball bearing block, okay? And this whole assembly can move up and down so that it can take measurements on the plate, which sits in this carriage, all right? And so when you need to take a measurement, this whole unit will come down, and this is also heavily involved in the calibration procedure, making sure that this measuring height is correct and optimized. All right, so just a small note there on that guy, and this is the motor for that right there. Yeah, so that is the motor for the measuring head right there. It almost seems like it's a bit too small to be moving this whole apparatus, but that's it. Alright, so back to the optic, the path of the light towards, we're getting pretty close to the detectors, but as I was saying, that there are, you can read from the bottom, you can read from the top, and we actually have two detectors right here. We have a detector A and a detector B. We actually have a third detector here, which is our ultra sensitive luminescence detector. This is an add-on option, so generally the instrument will come with both of these, but you've got two detectors for a few different reasons. One, so you can read bottom and the top simultaneously, and also you can read two different emission wavelengths at the same time, which can be helpful for certain applications. But how do you direct how do you know which detector you're directing the light to? Well, that is being done with these emission light selectors, which are, they have these little motors here and these mirrors that will direct the light based on what you've specified in your program. So you've got these two here, and then you've got these ports here for fiber optic, optic cables that are being, that are coming from the bottom read head. And then you can see here, this port here is where your photo multiplier tube assemblies are, and there's another port for this guy right there as well. And we can look at the top, and this is where both of you'd have detector A here, detector B, or I'm not sure if that's exactly correct, and that's where they would sit. All right, so, and again, you can see that they're positioned right here. We're going to open one of these up in a second. I have one of them open so that we can take a closer look at some of the internals there. This is your detector cooler, so this is just a fan with a Peltier element. You've got this big heat sink there for the Peltier element, and that's all that's doing, is just making sure the detectors are kept cool and so that they're operating, they're not overheating. And then of course, just like with the excitation light, these emission filters are also in that path. And so again, you can see that pretty clearly here. These are the lenses for where your PMTs would sit right above the emission filter rail, and so that's also in between the PMTs and the emission light selectors. So it's pretty cool. All right, now I think now would be a good time maybe to take a look at the inside of one of these PMTs. But real quick, this instrument also has some barcode readers so that you can actually read barcoded plates, and that might be more so for heavily regulated environments, or if you're doing high throughput screens where you barcoded your plates. That is what this assembly is for right here. All right, and of course you need a way to move the plate around so that it can do each of the wells, because the measuring head isn't moving anywhere. It's moving up and down, but it's not moving in the X and Y. And so that is done. Your plate would sit here, and it's being moved in the X and Y on these linear ball bearing rails. And there's also a X motor. Yes, so this is the X motor, so it's moving it back and forth, and you've got this belt here. And then I actually removed the Y motor because I stole a belt from this instrument, because that's the thing, these belts will go bad, they'll get chewed up because they're not the most robust, and then that'll start causing XY-track errors, which is actually what I'm dealing with on this other instrument that I was going to do this video on, which we'll get to in a minute. And of course, you want to clean these rails and lubricate them, with something like Tri-Flow or 3-in-1 oil to make sure they're kept clean and they're not sticking. That's what you'd want to do as well. So that's that. Here again, you've got the plate stacker set up, and we can pop this panel off so we can actually see what's going on here. Alright, so this is the stacker assembly, and you can see here you've got some motion components. A lot of Acme screws are being used, and the only function that this thing does is you're going to take a stack of plates. You're going to stack your plates up using this guide rail assembly, and all this is doing is the plates are going to start getting lower and lower in this stack as they're fed into the instrument, and then they're going to get piled up into this stack. That's all this assembly does. Now, There's a lot of moving parts in here, so you want to keep it greased. That's what I've got going on here, just to make sure that this thing is functioning properly. You've got a motor controller board here to drive each of these stepper motors, but yeah, it's an optional piece if you need to do high throughput. Alright, so I thought we could take a closer look at the detector for one of these instruments. Now this is actually an ultra sensitive luminescence detector that I pulled out of one of these guys, and you can see it says PMT preamplifier board on it, but this is actually the PMT. Now I believe you might have got a quick glance of this, but for the ultra sensitive luminescence detector, there's this pipe that runs down to a yeah, here it is actually. So this pipe is what the PMT sits in. Let's take a look at the circuitry. So, well, actually, let's start with the PMT. All right, so this is a Hamamatsu R647. I see Hamamatsu PMTs in a lot of our instrumentation, and I'm actually on their website right now. This is it, the R647 photomultiplier tube, head-on type, which means that sometimes you'll see these tubes where the it's the detector that you're basically light is going to be read from the side of it. This is head-on, so it's being read from here. That's where the photocathode is. And speaking of the photocathode, this is a bi-alkali photocathode. I believe it is potassium and rubidium, and gives you the spectral response, and it gives you some specs here. So we've got the anode cathode voltage is 1250 volts, and that's the max rating. It gives you some sensitivity parameters, just some pretty cool specs, and then it gives you the pinout for one of these, and these DYs, that stands for dinode, and so those are the electron multipliers within the tube, and you'll notice though that you've got this other adapter here, which is also from Hamamatsu. It's an E849, and that is they call these D-type socket assemblies. And so these are they're basically just voltage dividers that ensure that the correct voltage is being delivered to each of the dinodes inside the photomultiplier tube. And so you actually can see how that's hooked up here. This again is just a 11 resistor voltage divider, and it even gave you the total resistance of that divider here at 3.63 mega ohms. And from there you've got this would be your input, your high voltage cable here, which is shielded, and then you've got your output signal here, which is actually, I guess, comes as a BNC connector, although they don't have that here. But you can see this is your output cable here with the heavy shielding, and then the red is your high voltage and high voltage ground. So if we look, well, let's start at the top here. You can already see some similarities to the flash lamp, which also requires high voltage. You've got a transformer here, which is probably just taking that typical voltage that's been stepped down for the unit and then stepping that voltage up. And then if we go back to this side, you've got these big diodes. I believe this is the multiplier stepping that voltage up further, and this could be a switching transistor right here, this Q1 with C41 there as a filtering cap, because this is where your transformer is. I'm just guessing. Now this guy, I'm not going to take this off, but you clearly have some type of shielding going on here. This is for, I'm going to guess, the output. Let me see here. Yeah. So if we look here, this is the these are the output. This is the output to the PMT, and you can see the traces going directly underneath the shielding. This could be some kind of passive filtering for the signal, maybe, that they want to make sure they keep out any interference. And then as you've got some what I believe are, let's see if I can zoom in. I mean, these are op amps. I was just trying to get the part number off there. These say 272C, so these are just some precision op amps, all of them that are just acting as the preamp for this signal, where it will be further amplified on a different board. This is the output connector right there. All right, so that's pretty much the gist of it. And that's, I'm going to assume, how those other detectors are set up very similarly. Okay? All right, so getting kind of close to the end of the teardown here. There were just a couple other things that I wanted to touch on before we move on to actually looking into the service application that this instrument has that you can access to control the instrument at a lower level. But I did want to go over some of the other electronics. So first, starting with this is your AC input, and you got your filtering here, and then of course it moves on to this power supply here, which is providing this is just a Meanwell supply, probably non-proprietary. That is, I'm trying to read the label here. It looks like it's a 24-volt supply providing up to 13 amps. So pretty beefy supply, but that's going to be providing all of the DC voltage to this instrument. And then, as I was saying, for those high voltage needs, like for the flash lamp and the PMTs, that 24 volts is going to get stepped up, and then further stepped up by the multiplier circuits to at least 1,000 volts for the PMTs, and maybe even probably about the same for this the xenon flash lamp. Maybe more, but in my experience, they do tend to be anywhere from 300 to 1,000 volts, although this guy does look like a pretty large lamp. But anyway, now that we got that covered, this is the main board for the unit. And it's kind of interesting how they did this. I kind of like it, but this board, you've got the motherboard here, which this instrument communicates with via CAN. And the reason they're doing that is most likely because you've got so many motors, and so that kind of transmission, it lends itself a little bit better to that. So these are your CAN in and CAN outs right here. But what's interesting about this board is they've got these boards that they call nodes, and the topology on these is all the same. There's really nothing different about them. As far as what kind of chips they have on them. They're called dual stepper motor boards, and the reason for that is you've got these two motor controller ICs, so they can control up to 2 motors, and then you've got a microcontroller, which is a Renesas M16C series. I believe this one is, let's see if I can zoom in here. Yep, the M3060N type, and unfortunately I believe these have been made obsolete. But you can easily flash these if need be, if you do find a source for these, or if you've got an old board. Well, if you've got an old board lying around, you wouldn't need to, replace the micro, but it's very easy to flash these, all right? They're not read protected, and the instrument actually stores the hex files for each of these, or MOT files, right on the instrument. So here's your MOT folder. This is for all of the node boards. You've got the programming code right here. And so if ever one of these fails, you can easily just pop it back on. Now, it can be a little bit difficult to do that because you really would have to use a Renesas development tool to do this. I've done this before actually, and take this file, load it using the Renesas development tool. I forget which one they use, their Flash development software, and load it there, and then you'll be able to update the board in the service application that we update those calibration values or whatever it may be with the service mode application. But I really like how they did that. And then you've got this guy right here, which is the measuring interface. So this is where your PMTs are going to connect, the preamplifier boards, most likely for digital signal processing and further amplification, I would guess. You've got this Altera Flex, which is a PLD, and then another microcontroller down there. I haven't had a chance to look at what these ICs are on the board, but I'm assuming they would be, at least you have some additional amplification going on here. This is a, looks like your temperature control and laser driver board. So actually, depending on what option you've got, these units also have an additional excitation light source that is a laser for what's known as AlphaScreen assays, which I'm not going to get into, but they, I believe this 2104 is outfitted with that, and that laser is also hanging out in the back of the instrument, and then there is a optic cable that brings it to the measuring head. All right, it actually does pop out at the let me see, where is my, yes, here we go. So if you look at the excitation light selector, you can see that there's those two holes there. So that one that's empty, that's where the light path the optic cable for the AlphaScreen laser would connect, so that you can match it up with an AlphaScreen style mirror module. All right. So yeah, that is the main board. Very modular, very easy to work on, in my experience. I think that just about covers the teardown. So let's get into what I'm doing with this other instrument, and I can kind of go over a bit of the service application that you can access. Alright, so this is the other Envision that we have that was having some issues with the XYTrack. It was throwing some errors like the one that I embedded in the video earlier at the start. This is obviously an older model. It's the 2100. Okay, so this was the first generation that PerkinElmer put out. It's getting obsolete. In fact, if you ever opened the back of one of these up, it has the main board is configured very in the same way as far as how they set it up, but you can clearly see that they're very different as far as the ICs are much older, and just, it's a little bit different, but for the most part it's pretty similar. And you can see that from here. Now this one is missing some of the additional options. So for example, there is no excitation, there's no ultra-sensitive luminescence detector, but you still have your two detectors A and B here. And yeah, so, and of course your detector cooler. But yeah, so the XYTrack is having some issues. Now I had mentioned that, these belts, the teeth can get all chewed up and cause all kinds of issues. So I've already replaced those a long time ago, not too long ago, because again, for this same issue, and it resolved it and everything was fine. And again, lubricating these guide rails is also what you want to do, and we've done that. So it had been a while since I'd done that, so I decided to lubricate them again. I did check the belts just to make sure that there weren't no missing teeth, no tears, everything looks good. One thing that you can do to kind of run the instrument if you need, because if you want to just check a few things like run a dummy plate, you can actually keep the lid open and trick it, because it's just using a Hall sensor to sense whether or not this lid is closed. And so I've just got a magnet there tricking it. But you don't need that for the service mode application, which is what I'm going to show you right now. Now, to access this guy, you're going to want to go to your program files and then PerkinElmer Life Sciences, and then you're going to go to the Wservice folder. All right, and you're going to click on this application here that says Wservice .exe. So we're going to double click on that, and then this login is going to come in. And now you can type any type of username you want. We can type it UT for YouTube, and then our password is going to be lowercase advanced service, and there's no space. I'll put it in the I'll embed it in the video so you guys can see. I'm going to click OK. All right, and you can see it's resetting the instrument. These are all your hardware options on the side here. So you've got the barcode reader, buttons, detector cooler, the diode height changer for the photo. That's one thing I forgot to mention. There are a series of photodiodes that are just checking the intensity of excitation light, so that it knows, it can, I guess, also check for background light as well, making sure that that's not too low. But anyway, so that is what that thing does. You've got, again, the dual emission light selectors or light switch, your excitation filter changer, excitation light controller or the light selector, same thing. The measuring height changer, measuring head. So anyway, yeah, mirror block changer, the mirror module assembly that we looked at, all of these things so that you can kind of control them at a lower level. But anyway, what we need to do first is create an instrument, and it's just going to read the serial number and start up get all of the hardware ready for initialization. So it's doing that now, or it's trying to. Sometimes this guy can be a little bit finicky. For some reason on this computer, when you exit out of the actual Envision software that you would use for controlling the instrument in normal operation, when you exit out of that and you try to start this guy up, it does cause some problems. You might have to try it a couple times depending on how old your instrument is, or that doesn't happen with the other one, but it does happen with this one. And now it's asking us to initialize, so we're going to click yes. And you can hear that the instrument is initializing. It's really just moving all of the internal motors through. It's homing them. It's just running everything through a quick startup test. And that isn't, now if something is wrong, it's going to throw an error for that particular module or hardware option. And in this case, it didn't, so that's good. But let's click on the instrument of the hardware that we're interested in. Let's click on this XYTrack. All right. And so what's cool about this is you can initialize it, you can reset it, and if you go to tests, you have these basic mover tests that you can do. So if we go to, now I already performed these tests, and you can actually see I did it for the X and Y motors, and it succeeded. So, but if we click on the X motor, you check on that, you click apply, and now it's brought us to this application where we can run loops. So for example, I can run a random loop with 10 movements and then click random run. And so why don't we do that so you guys can actually see what happens inside the instrument. So we're going to click that. So you can see, now it is moving a little bit in the Y, but this is mainly a test for the X, okay? I put a plate on there just to, simulate the weight of a plate, just to make the conditions more realistic. But you can see that this random loop test for the X motor worked just fine, and it'll even tell you the steps, time, position, error, and I guess that it means just the encoder error. So that doesn't necessarily mean that there was an issue, but it might have just been off by a little bit. So we can close out of this, and let's try the Y. Now I think that is where this guy was having some issues, because it was happening for the end user when they were trying to unload the plate. It wouldn't unload the plate. It would make a horrendous noise, and then it would throw an error. So let's try the Y mover test, and we're just going to do the same thing. And you can add as many loops as you want. We'll just do 11, and then we'll just click random run and see what happens. I mean, it sounds pretty good. Sounds nice and clean. It's not making any, it's not getting tripped up at all. And like with the X motor test, this test completed without any issues. So we're going to close out of that. But that's the kind of capability that you have using this service mode. Now, you can do a lot more than just these basic mover tests. This is where you would calibrate the instrument if you had the calibration tools, which PerkinElmer does not give you. Now, you can perform some calibrations with a lot of the calibrations are done using mirror modules. Those PerkinElmer obviously has to sell you so that you do a variety of tests with this instrument. So, for example, if you want to do the mirror module calibration, and you can run it through these tests, you just need a, for example, the mirror block offset test, or positions 1 through 4, you just need a specific mirror module that, I forget which one that you would need, but there's actually, to help you out, if you go to, this is a good resource, but if we go to MLR4, this folder here, and we go to MLR4 Service Help, this will provide you, if we go to the service manual, which is not the full service manual for the instrument, but if we go to calibration instructions, now this is actually an issue that I've ran into with, for example, I think it's just this PC, but for some reason I can't access the help application on this PC. I forgot about that, but I can show it to you on the other one. Okay, so this is what I was referring to, the calibrations chart, and it will basically walk you through for each of the hardware options, detector coiler, the filter changer, the emission, both of the filter changers, you know, the plate door. It'll walk you through all of the hardware options, and basically, I mean, you can really say it's really bare bones, and you can kind of see what PerkinElmer's tech was saying by it's just enough to get you into trouble, and he's probably right. So unless you're really technical, you really understand these instruments, and you just need a little bit of a guide, I wouldn't try these, but it's here if you need it. But there are other really helpful resources in this service manual, such as going over the mechanical construction, providing a bit more details on the instrument itself. Now, this help app is more specific to that older instrument here, and I can give you an example. So if we look at the mirror module changer, this is the dual stepper motor board, and you can see this is not at all what this board looks like in the newer version. So it can trip you up a bit. Just be aware of that this is going to look a lot more similar to the 2100 Envision And for the newer models, it can still be helpful, but it's not going to be a direct reference, that's for sure. Alright, so now I'm just going to run a quick dummy test, just with a blank plate, make sure that the instrument is able to complete a an experiment. And this is actually the same experiment that the end user was running when they had their issue. So I like to try to duplicate that as much as I can, just to make sure everything is good. Again, the basic mover tests, the random loop tests for the X and Y motors, completed without any errors. And the thing is, I was able to recreate this error prior to lubricating the linear ball bearing rails and doing some of the service mode tests. But so I definitely saw it, but it's looking good so far. Hopefully I don't jinx it. Alright, it's a moment of truth. Is it going to unload it? And it did. So, alright. Now, I've actually done this a few times already, and I haven't been able to recreate it since lubricating the linear ball bearing rail. So that could have been the problem. Maybe they were just getting a little bit sticky, because again, the drive belts look completely fine. There's no missing teeth. So that's really, in most cases, it's going to be one or two or both of those that's causing these kinds of errors. But it looks like we're in good shape, so I'm going to finish up. And I think that's going to be the end of this video. I hope you guys found this interesting or helpful, and if you have any questions or comments, feedback, leave it in the comments. And I'll catch you at the next repair. All right.